Okay, we have a function here where it's function to the power of function, and there's actually another power of function. So it's actually in this form. Okay. So every time if you want to bring down a function from an exponent, we need to log both sides. But there's two exponents here, so this means we will need to log both sides twice to bring all the exponents down, which are functions themselves. So let me do that first by first setting y equal to x to the power of x to the power of x to the power of x. Log both sides. So we're logging both sides instead of log because log is easier to differentiate than log. Right. And this can come down to the front using the third law of logs. Okay, again, we still have exponent, which is x, right, in terms of x. So we need to log both sides one more time. You get that? So this right here, we can split it using the first log law, which is if you have two things multiplied together, that can be expressed as the sum of logs, like this. The second one is log of log though, right? Ln of log. Okay, so let's simplify the expression. This x can come out to the front. We get x ln of x. Ln of that x also can come out to the front. Okay, this one here we can expand one more time. Ln of x plus ln of x. Okay. Meanwhile, on the left side we have ln of y. Now we're ready to differentiate both sides. Okay, so here this is a composition of function ln into ln, right? So we get 1 over ln of y chained by the derivative of ln of y, which is 1 over y, and then the derivative of y, which is a function of x, y prime. This is going to be product rule, right? So ln of x, if you differentiate x, you get 1, plus x times by 1 over x, plus the derivative of that is 1 over x. This last term here, we get 1 over ln of x times by 1 over x. So let's clean that up. We have y prime, right, which is a derivative function, is equal to ln of x plus 1 over x plus 1 over x times ln of x. Now all of that needs to be multiplied by this, right? Which is y times ln of y. Now our goal is to find f prime at 2. Okay, so the x terms are easy. You plug in ln of 2 plus 1 half 2 ln of 2. Now y is this. So we get 2 to the power of 2, 2 to the power of 2, which is 4 to the power of 4, which is 2 to the power of 8, because 4 is 2 squared, so 4 times 2 is 8, 2 to the power of 8. So I'm just going to leave it in that form for now, because all the answer is not in, it's still in exponent form. It's not in a numerical form where the number is really big. Okay, so what's ln of y now? So ln of y is right here. We know that's going to be ln of 2 to the power of 8, which is 8 times ln of 2. Okay, so we have what ln of y is equal to, and we also have what y is equal to. Let's replace that with the values here. So y is 2 to the power of 8. Ln of y is 8 times ln of 2. Okay, the first thing I'm going to do is multiply this ln of 2 into the bracket. Only that. Okay, just the ln of 2. Then we get ln of 2 squared plus, actually let's add these two. You get 3 over 2. 3 over 2 ln of 2 plus half. You get 2 to the power of 8 times 4, which is 2 to the power of 3. Okay, now inside the bracket, there is still fraction, and I can get rid of that fraction if I just multiply the bracket by 2. So I'm going to take 1 factor of 2 from here. Okay, so if you do that, we're only left with now 2 to the power of 8 and 2 squared. And in the bracket, everything will be multiplied by 2. So you get 2 ln of 2 squared plus 3 ln of 2 plus 1. Okay, let me let ln of 2 equal to a. We get 2a squared plus 3a plus 1. The outside is 2 to the power of 10. This is factorable. So by trial and error factoring, you get 2a plus 1 times by a plus 1. Let me replace the a back with ln of 2. 2 ln of 2 plus 1. Ln of 2 plus 1. 2 to the power of 10. So our answer is A, right?